Good afternoon and welcome to Algebra 2. Let's take a look at lesson 8.5c. Assignment 8.5c is an online submission due on Tuesday of this week. So the solutions are already online. Let's begin learning how to solve logarithmic equations. First step is going to be, if you have multiple logs, we want to combine multiple logs. And what that means is that if there's 4 logs or 5 logs, we need to smash them down or condense them, if you will, into a single log using log properties. Combine multiple logs and then isolate it so that it's all by itself on one side of the equation. Now, you don't, like, for example, in the first problem, you only have 1 log. It's not until problem 4 that we see multiple logs. So this first step in the strategy will not apply until problem 4. For all these other problems, you just jump straight to step 2, which is change to exponential form. So this is where you'll use the code EF for exponential form. I'm going to put that in green because that's how it generally shows. It always shows up. The codes always show up in green on the solutions. Our third and final step is to solve the resulting equation. So solve for, so sometimes it's x, it's usually x, but it can be others. There's a note here. Remember, that the domain of logs are positive numbers only. So if you get an answer of -10, then something has gone wrong. You would have to reject -10 because the log base 4 of 5 times -10, that you can never put a negative number into a log function. And you're reminded of this by all the work that you've done with graphs. Like, think of all the log graphs, all the log parent graphs. When the Batmobiles came along the x-axis, they never found golf balls on the negative part of the x-axis, never at 0. The only golf balls that were available for the Batmobile to clean off the street were positive golf balls. So if you're solving a log equation and a negative solution comes up, reject it. Here we go, our first example. We're going to call this the original equation. It's already happening, thanks to Ethan. So it's isolated, so let's go into EF. Now, exponential form is really a signal that it's time to use the arrow thing. 4 to the -1 equals 5x. Here's how I'm going to write it. I'm going to reverse it so that we have 5x equals 4 to the -1 power. Using the arrow thing, informally expressed. Formally, we talk about exponential form, but informally, we talk about the arrow thing. We got 5 to the x equals 4 to the -1. And for some of you, that might be the most difficult part of the problem, is just getting the equation transformed from log form to exponent form. Any questions on how I was able to pull this off using the arrow thing? Looks like you're increasingly comfortable with that. I'm going to, instead of D5, I'm going to write M 1/5. Look at the advantage of multiplying both sides by 1/5. We get, on the left is x, 4 to the -1 is 1/4. Multiplied by 1/5 gives us an answer of 1/20. Now, if you want to check it in your head, put a 1/20 in for x. 5 times a 20th is 5/20 or 1/4. In the log base 4 of 1/4, think of 1/4 as 4 to the -1. So log base 4 of 4 to the -1, sure enough, it checks out to be -1. Here, would you try number 2 on your own? See if you can solve for x by using these codes, OE, exponent form, EF, A5, and M 1/3. So try to write a line of algebra for all 3 of these codes. Anna, do you have a question?
Why do you multiply by 1/3?
Because I have a fraction involved here. 4 to the negative 1 is the fraction 1/4. And I'd prefer not to divide a fraction by a number. So when fractions are involved, it's better to multiply by the reciprocal. D5 would leave us with this. It would leave us with 1/4 over 5. And a fraction that's inside of a fraction can often trigger a fair bit of confusion, believe you me.
Believe you me.
Bethany, go ahead.
Wait, how did you get the 5 over to the other side though? Because
Right, how did I get the 5 the other side?
yeah.
M1/5 means multiply both sides by 1/5.
Oh.
So when you multiply this by 1/5, you get X. When you multiply that by 1/5, you get 1/20.
Oh.
I'd like all of you to try number 2 on your own. All right, so Jay, what did you get for log form, or for exponent form on this one?
I got 3x is equal to 25.
You know, let's write this as 3x minus 5 is equal to, and then what goes over here?
20.
No, it's 10 squared,
Oh.
which is 100.
Oh,
So you gotta watch out. I would recommend, to avoid making that mistake on Friday's test, I would recommend putting the invisible 10, making the invisible visible, and then drawing the 2 arrows. The first arrow always goes from the base to the other side of the equation, and the second arrow takes us to the input. So if you draw the arrows, you'll probably get a higher score on Friday's test. Draw the arrows. That gives you 10 squared, and then adding 5 takes us to 3x is 105. So I know it looks like the final answer is 105 thirds, but 105 thirds does reduce. I know that 105 is a multiple of 3 because 1 plus 0 plus 5, or 6, is a multiple of 3. So that's going to come down to 3, 5. 35 times 3 is 105. Final answer. Any questions on how to get 35 on problem 2? We're going to keep rolling then. What do you think after OE for original equation? The first code is going to be on problem 3. Sophia?
Yeah.
And yes, for what does EF stand? Exponent form is correct. So let's look at the exponent form here using the arrow thing. Jay, back to you on this. I want to give you a chance to succeed.
Would it be 10x minus 3 equals 5 to the 0?
Yeah, 10x minus 3 equals 5 to the 0. You see 5 to the 0 is 10x minus 3. Now finish solving for x. When you're done, check up here to see if we agree. There's no fraction involved here, so instead of m1/10, I'm just going to use d10. Notice how the codes give us a chance to talk about the thinking process. 4/10 reduces to 2/5, which does check out. Any questions on problem 3? All right, let's just move right ahead here then to just the simplification process. This is a review from earlier in the chapter. You see, we have a difference of logs. And the difference of logs is the log of some word that begins with Q. Can someone give me the word that begins with Q that would go in the blank? The difference of logs is the log of a blank. Who thinks of got it? Owen, do you have it?
Quotient.
Quotient. And the quotient of x and 5 is x over 5. Now it's time to use the EF code exponent form. So what would exponent form be this time? Well, it's going to be x over 5 equals something. It's going to be x over 5 equals what? Help me out with that one, please. Jack.
X equals.
No, it's x over 5 equals what?
10.
Nice work. 10 to the third is correct. We're going to do an M5 here to wrap it up. M5 gives us x equals 1,000 times 5 is 5,000. What questions, if any, would you like to ask on number 4? Okay, if we're going too fast, just raise your hand. Raise your hand if you feel like this is going too fast. You need to take a little more time. Maybe slow down a little bit. Okay, page 2. We're getting there. Now, here we have multiple logs once again. And before we even talk about the sum of logs is the log of a product, let's first of all put the hats on. If there's any hats on the ground or tucked away into a bag, if you got some hat in airplane mode in your bag, take it out, put it back on your head. Let's write this as the log base 3 of x squared plus the log base 3 of 5 equals 2. So the code for that is when you use an exponent property, just say you're simplifying. You're going to simplify the expression. In fact, we're going to simplify it again using a log property. It's the one that says the log of the sum of logs is a log of a product. So raise your hand if you think you know what the single log expression is. We're condensing the 2 log expression to a 1 log expression. So what do you think? Daniel? First of all, can you tell me the word that begins with a P that would go in the blank? The sum of logs is the log of a blank.
It starts with a P.
It starts with a P.
Oh, shit.
Well, when we had a difference of logs, it was the log of a somewhere
Product.
that
Product.
it was quotient,
It's quotient,
or when
not
it's a
product.
difference. But when it's a plus sign, the sum of logs is a log of a product. So can you tell me what the product of these 2 expressions is? What's the product of x squared and 5?
5x. 5 by 5.
You're making it too hard. What's the product? Like if I said, what's the product of 3 and 10, you'd say 30, you just multiply together. What's the product of x squared and 5?
5x squared.
5x squared, that's all there is to it. So got 5x squared. Now that we have a single log expression, we can put it in exponent form. So exponent form in this particular case is going to be 5x squared equals something. And what is that something to which 5x squared is equal? Help me out with that one, please, Bethany. Well, what's the invisible base here?
1.
No, when there's an invisible base, it's always 10. Thanks, Lauren. Thank you. That's good.
So then you divide it to like
So, do you know how to do the arrow thing, Bethany?
No.
Come and draw the first arrow. Come on up. Here, I'll coach you through it. Now, we've been talking about the arrow thing like every day for a long time. So if you don't know what that means, let's figure it out. You always draw the arrow from the base.
Right here you want me?
Yeah, from the base up, yeah, okay. Then draw the second arrow. Pretty close, pretty close. Thank you. Thank you, Bethany. So, a little bit of coaching for you. When you get back to your seat, look up here and watch what I'm going to do to your second arrow. Your second arrow, I'm just going to smush it a little bit here so it's pointing to the 5x squared. Okay? So that's the 5x squared equals, the first arrow is 10. Your arrow says 10 to the second power. So I'm going to write 10 to the second power. And 5x squared to, yeah. Now, Owen, go ahead.
Where'd the 3 go? Why is it 10?
Yeah, that is weird. So what happened was that the 3 got dropped. So that's actually a mistake. Let's correct it. I could tell when your hands were up the way they were, I could tell there was something wrong. So it's not really an invisible 10. What happened was I forgot to copy down the 3. So it's not really 10 to the second, it's actually 3 to the second power. So let's fix that. Change the 10 to a 3. So here we go. We've got 5x squared is 3 squared. So now when we simplify that, we get 5x squared. In fact, I'm going to divide both sides by 5 to get 9/5. The code for that is D5. Now, one code that maybe you haven't seen for a few days is DSR. That's the definition of square roots, which reminds us that we need a plus or minus in here. It's plus or minus 3 over the square root of 5. The square root of 9 is 3, the plus or minus belongs there. And then, when you rationalize, back in unit 7, you would rationalize by multiplying by 1 in the form of radical 5 over radical 5. So it appears that the final answer is plus or minus 3 radical 5 over 5. However, remember the domain of log functions is positive numbers only. and we can't put a negative number into a log, so you have to reject the negative 3 radical 5 to get the final answer of positive 3 radical 5 over 5. So, to get full credit on this, you would have to have the plus or minus, and then you'd have to reject the negative based on the domain issue. If you forget the plus or minus in the first place, then you would actually lose 2 points. So the plus or minus is 1 point, and then rejecting the negative gives you the second point. Do you have any follow-up questions on problem 5? All right, now, before we do this last one, I just want to let you know that the final 4 problems in this lesson are mental math problems. So I want to do 7, 8, 9, 10 as just kind of a change of pace. Then we're going to go back, we're going to swing back to number 6, just like earlier today. Jay, do you remember that when we swung back to number 6? We're going to do it again. Mental math, the nice thing about mental math is that you don't have to show any work, just x equals and the answer. By the way, 5 to what power is 25? Glass?
5.
I think x would have to be 2 to make the arrow thing true, because 5 to the second power would be 25.
Yes, 25.
Raise your hand if you think you know the exponent that you'd have to place on 125 to get 5. Just raise your hand if you think you got it. Using mental math, what's that one got to be? Andrew, tell me what you think it is. Raise your hand if you agree with Andrew's answer. He thinks that 125 to the 1/3 power gives you 5. Raise your hand if you disagree. Raise your hand if, to be honest, you're not sure. Okay? Raise your hand if you're in some other category, like a 4th category. All right, so Gerald, what category are you in on this?
I'm in.
You're in, so you agree. You agree with this? Turns
I
out
agree.
Andrew's answer is correct. X is 1/3. Try problems 9 and 10 on your own. These are mental math problems. Now, on problem 9, you have to think of some number such that when you raise it to the 2nd power, you get 81. Who thinks it got that one? What number must that be such that when you square it, you get 81? What is it, class? It's got to be 9. Now, this one's a little trickier, but I think you can do it. If you take some number, just think of a number so that when you add 1 and then cube it, you get 8. What's that one got to be, Jay?
1.
It's got to be 1, because 1 plus 1 is 2, 2 cubed is 8. Those are mental math problems. Now we can swing back to problem 6. Unless you have any questions on the mental math problems that came up actually surprisingly quickly. Here we go. Last one. Fair bit of detail here. So after this, I'll hand out the review packet. We've got the original equation is here. I have to combine the logs on the same side of the equation. So I have to do an s log of x minus 5. I have to subtract log of x minus 5 from both sides. We've got log of 2x minus 3 minus log of x minus 5 equals 1. Now is this a sum of logs or a difference of logs? Class? Yeah, it's a difference of logs. So are you going to rewrite it as the log of a product or the log of a quotient? If you said quotient, that's correct. So go ahead and rewrite this as a single log. The log of a quotient is equal to 1. When you're done with your quotient, look up here to see if it matches mine. Okay. Hope you got 2x minus 3 over x minus 5. Let's pause here. Any questions on how to rewrite this as the log of a quotient? Okay, there's an invisible 10 this time. And if you draw the arrow thing, you get 10 to the 1st power. So the exponent form is going to be the quotient 2x minus 3 over x minus 5 is 10. And here's a move you don't see every day. Sometimes you walk in here, you see dance moves that you definitely don't see every day. Here is an algebraic move that I guarantee you do not see every day. And it's the move mx minus 5. If you multiply both sides of this equation by x minus 5, distributing on the fly, you get 2x minus 5 is 10x minus 50. 2x minus 5 equals 10x minus 50. Finish it up from there, solve this equation for x. This is a twofer. We're going to both subtract 10x and add 5. D negative 8 gives us 45/8 for the final answer. It does check out. So that concludes our lesson for today. I've got the review packet. Not only is assignment 8.5C, there it is, it's an online submission. 8.5C is due tomorrow, in addition to the, you might want to get started on the problem set.